Hello everyone, this is the day 4 of Data Science series. Unit 4 Data Preparation Phase to Model the Data. How to partition the data in Python. In this topic, we will cover all the preparation phase of the model data. So, the partitioning data finally typically involves splitting it into subsets such as training, validations, and testing test sets, which is essential for machine learning to evaluate and optimize model performance in Python. You can partition data using libraries like scikit-learn, pandas, or numpy. Here are some common methods. We use all three topics covered to this chapter using trend test split from scikit-learn. Trend test split is straightforward for creating trend test, validation test split. See this example of the trend test example. Second, manual split using numpy. This approach is useful if you need full control over the indirect randomness. Import num_np number of import values, shuffle indices np.arrange. This is all the example of the manual split. The code are copy and paste to this Google Colab simply and output will be generated using pandas for random sampling. If you are working with a data frame, you can randomly sample and then split the data. Import as panda. Assume data is a data frame with the target column named target. So trend data sample, temp data, temporary data is temp data dot drop. Separate future and target. How to balance the training data sets in Python. So, the balancing a training dataset is crucial when dealing with imbalanced classes, as it improves model performance and prevents it from being biased towards the majority class. There are several ways to achieve this in Python, particularly using imbalanced learn, pandas, and numpy. Balancing is datasets. Only the datasets using for in this step using imbalanced learn for oversampling and undersampling. The invariant learn libraries provide utilities for oversampling, increasing instance of minority class, and undersampling, reducing. It is a increasing and reducing functions of the majority class. Simply install invariant learn, pip install invariant learn. It is not install type, so we will generate automatically Google Colab to this invariant learn seed. Oversampling with random oversampler from learn oversampling import random oversampler. Suppose X train is the feature set and Y train is the target variable. Rows random oversampling. This is the syntax for the random oversampling. Undersampling with random undersampler. From in from in learn undersampling report random undersampler. Random undersampler, random state 42. SMOT. This is the full form of synthetic minority oversampling technique. Sy- sy- Synthetic minority oversampling technique generates synthetic samples for the minority class by interpolating between existing samples, making it especially useful for continuous data. From in from IMB-learn oversampling import SMOTE random state. This is an example of from. For example, I have created to this example shortly. Syntax are generated using pandas to manually balance data. This approach works well for smaller datasets where you want to have full control over the balancing process. And third is using class weight in models. Some models allow you to assign weights to class, which give higher importance to the minority class without changing the dataset size. Here's an example with scikit-learn's random forest classifier. This is the example from assemble import random forest classifier. Data augmentations from image or text. This in image or text classification, you can apply argumentation technique to generate new samples for the minority class, such as rotating, flipping, or adding noise in image data sets, or changing wording in text data sets. So choosing the right technique. So what the technique will be provided you. So random oversampling and undersampling. And SMOTE, it is a useful when your sheet needs synthetic data in continuous feature spaces. Class weights, suitable when you don't want to alter the data sets but have supports in the model. How to build card decision tree using Python. Card decision tree, it is stand for classification and regression tree. Building a classification and regression tree in Python is straightforward with libraries like scikit-learn. Card decision tree are used for both classification and regression tasks and involving splitting the datasets at various points to maximize information gain. Install required libraries. If you have installed scikit-learn, you can do so with pip install scikit-learn. Building a card decision tree in Python. Step 1. Import libraries and load the data. So we have created the card functions. This is the target variable and the card functions created by this. Step 2. Split the data into training and test sets. Xtrain, test, ytrain, bytest. Initialize the train into the card model. Classification tree. Initialize classifier with parameters. Overlifting. Classifications stand for CLR. Decision tree classifier. Regression tree for continuous target values. Evaluate the model. Classification model evaluation. From sklearn, matrices import accuracy score classification report. See the all examples will be created step by step. Regression model evaluation. Visualize the decision tree. Visualizing a decision tree helps interpret the split and decisions rules. Here how to plot it using plot tree from scikit-learn. The figure size is plot is 12, 8. 3 plot tree fine tuning the card model. You can adjust parameter like max depth, min sample split, min sample leaf. Full example for classification putting it all together from. This is the example for full full card. See the example. This is the full example of this all theory we have created simply. The code will be automatically generated output for classification put in all together. Petal length, gain, petal length, petal width, petal height, all samples and values, class, subclass, macro, accuracy, weighted average, all the precisions, recall, F1 score and supports we have created. The class import from sklearn.tree, from sklearn.model selections and the trend test split. This is the output of the code. How to build C 5.0 decision tree using Python. C 5.0 is an advanced tree algorithm and an interpretation and an improvement over the older C 4.5. This is the 4.5 algorithm and the C 5.4 5.0 is an advanced decision tree. While scikit-learn includes support for card classification and regression tree, it doesn't directly support C 5.0. However, there are few workarounds you can use in Python. Using Python wrapper for C 5.0 with RPY2. Using sklearn with similar in hyperparameters. Using RPY2 runs C 5.0 from R. First install RPY, PIP install RPY, implementing C5.0 in Python using RPY. Import pandas as PD from this is the header files of the code and for example load data, precise the data, activate pandas library and the functions. All data load from sklearn. Simulating C 5.0 with scikit-learn and decision tree classifier. C5 in information gain ratio for splitting like C4.45 while SK scikit-learn decision tree classifier use Gini impurity and entropy. Key difference between C 5.0 and CART implementations. Splitting criteria, pruning, alternative Python libraries similar to C.5. There are no direct open source implementations of C 5.0 in Python. However, XGBoost or LightGVM are advanced tree-based algorithms. How to build a random forest in Python. Building a random forest in Python is straightforward with scikit. A random forest is an ensemble learning method that builds multiple decision trees during training and combines their output to improve accuracy and reduce overfitting. Install required libraries. This libraries make sure to building a random forest model. Make sure base scikit-learn installed. Copy code. PIP installs scikit-learn. Building a random forest model. Step 1. Import libraries and load data. Step 2. Split the data into training and test sets. Step 3. Initialize and train the random forest mode. Regression example for contiguous target value. Classification model evaluations examples and the fine-tuning the random forest model. Future importance. Random forest provide future importance scores which can help you understand which features contribute the most to model decisions. Python. Full example putting it all together. We have created all steps. The example we seen from I have created also the all example in this step by step. So this is the code. So created all the model test in putting it all together, fine tuning, random forest model, regression model, and classification model. All the parts should be corrected to these portions and output finally we have generated shortly. So the code will be copied and pasted to this Google Colabs. Our output generated. Thank you.